A slight risk for severe weather exists today over a broad region of the South, including portions of Tennessee, Mississippi, some of Alabama, Arkansas, Louisiana, and Texas, with a pretty large marginal risk surrounding this, going all the way up to southern Illinois and Indiana, and all the way down into regions in central eastern Texas, more portions of Louisiana, and a bigger portion of Alabama. This is going to be an all hazards play. We got tornado risk 5%, 15% wind risk, and 15% hail risk here. So pretty standard all hazards risk at play here. And in particular, it's going to be due to a stagnant cold front, which we'll be looking at in a second. First of all, though, I do want to look at our model runs. So I'm using the wrap initialization here at 12Z. Going forward with time a little bit. Do we have 15Z? It doesn't look. 15Z should get us just enough in time. So we can look at our 15Z drop progression here. So what we're noticing to start with here is we have a pretty broad troughing up here in the northern United States. And you can see the flow here showing that troughing, lower geopotential heights up here and increasing as you get further down south. Throughout the day, we mostly have zonal flow over our region with a little bit of a southerly component, but for the most part, pretty zonal flow and not super intense for the jet stream. Let's move down to 500 millibars now, and we'll see a little bit of different story. This trough is a little bit deeper here at 500 millibars. We have more of this enhanced upper level flow, really helping our setup. So it's a little bit of glancing below, but you can see pretty well here. There is this enhanced flow out ahead of whatever we'll be seeing down there at the surface. Let's look at the vorticity as well. Not very intense vorticity advection. We do have this little band of vorticity here, which we'll be looking out for. In particular, we don't have a large scale. This would be our main portion for vorticity advection up here in the Midwest, but not really down here in the South. 700 millibars. Let's look for any short waves. You can see a little bit of kinks in the flow. Maybe one right here, one defined here, one already ahead, but not a very well defined shortwave anywhere in here. Just general height falls throughout the day here. That height falls help to and help rising motion. So lowering the geopotential height for 700 millibars throughout the day will help to indicate rising motion in our risk area. So we do see very slight but steady height falls throughout the day in some portions of our risk area, especially more up north. Let's check 850 millibars as well here. You can see we do have a little bit of a lower level jet to start the day out. It looks like this will actually decrease a little bit throughout the day, but we do still have some semblances of it. Pretty widespread 30 knots, but not really an intense low level jet as we're used to. Let's look at our temperature here. We do some warm air advection, so you can see in our region beginning the day here, 11 degrees Celsius about, and throughout the day here you do get that warm air advection. You can look at temperature advection specifically, and you can see what I'm talking about. That warm air advection is on its way at that point. Moisture is definitely at play. You can definitely see the high pressure ridge out, high pressure ridging we have out here is going to help to transport some of that moisture. Put our big upper level lows here. But that moisture transport is really going to be, it's going to happen. So you can see it pretty well here at about 0Z. This high pressure ridging, not super intense, but the low pressure here, again, both sides are going to help to funnel moisture up into our risk area. So low level moisture is pretty good for this setup. And finally, let's look at the surface. So with our 500 millibar low, we saw that a lot of plume of vorticity to help spin up a surface low up in the upper Midwest, northern Midwest here, Minnesota. But the main thing is we're going to have a trailing cold front going on throughout this setup. Did not mean to take a sounding there. A trailing cold front. So you can see pretty clearly here, right, a stagnant cold front. Let's actually zoom in closer out here. So here's our initialization, and you can see pretty clearly where our cold front is. I'm going to draw it out here for you guys. Right in this vicinity here. So you can see our wind shift. We have northerly winds here and southwesterly winds here, as well as a little bit of a kink in the contours. We can see it right here. Pretty clear pressure tongue right there. So we do have this trailing cold front. And we could even, put a very minimal surface low out here even. A little bit of a kind of warm front right here as well, because you can see we have southerly warm air advection here compared to easterly moving winds there. So we should intend to see a little bit of a warm front as the day goes on there. Maybe even stationary, but for the most part, we do have a little bit of even surface cyclogenesis showing here. But the stagnant cold front here is going to be our real play, main player here. So here's 15Z here 6 hours later at 21Z. 15Z is 10 o'clock Central Time. 21 is going to be our 3 o'clock Central Time. Or, sorry, 4 o'clock Central Time, excuse me. But yeah, you can see our cold front after 6 hours really has not moved. It's a very minimal moving for cold fronts. Cold fronts usually are pretty quick. In our case, though, this cold front is going to be very slow moving, which should allow storms that form on it to they'll cluster up, but they won't they cannot run the line if they become discrete. That's going to be a main forcing at play today. Let's look at our moisture. To begin here at 15Z wrap, we have pretty widespread 60s dew points over much of Texas and Louisiana. And then as time moves on, it looks like these actually kind of increase, especially as this front begins to push its way down here. You can see that moisture though, but we did talk about that southerly air advection, warmer air advection from the Gulf, pretty clear throughout this run here. We have pretty widespread 10 knots across the field. Looks like it decreased a little bit into the nighttime hours, but that is to be expected. Let's look at our surface ops to see how true this really is right now. And yeah, we have a pretty good look at this as well. Let's do our surface analysis here. We can put a cold front. Again, same location we talked about. This is observations, I believe, from 16Z. Oops, let's see. Yeah, or 15Z it looks like. Okay, so right about when wrap initialized as well. Look out in our broad open warm sector here. Yeah, 15 knots here, 10 knots here. So again, pretty widespread 10 knots, even some 20 knots closer to that cold front. So we definitely have that southerly warm air advection. A little bit veered out here in Texas, so this isn't some big time tornado setup, but we do have that the possibility for QLCS tornadoes if this line really gets going, and I'll show you that in the cams in a second. But yeah, you can see in our surface analysis here what I was talking about. Here is our satellite. We'll go through a little loop here. You can see we have some ongoing rain showers out here in Indiana, Ohio, Kentucky, west of the Appalachians there. We zoom in. Let's zoom into our. We'll do this sector. This will work fine. Looking here in Arkansas, Louisiana, we have, there is some cloud cover, but it's not super thick, so that will help to begin heating, surface heating. You can tell that a lot of these clouds are actually lower level clouds due to the way they are moving. The vast majority of some of these are moving about this direction. We do have some more southerly component, so we do have cloud cover at every level, and we're still waiting on some of that clearing to go on though. I believe you can kind of see our stagnant cold front back there. Let's pause the loop right here. Oops, did not work. Let's pause the loop right at the end. I'm actually gonna move over a little bit here. Let's look at our loop one more time. Yeah, I'd probably place our cold front somewhere in this vicinity. Again, that's what we looked at in the surface analysis right here. But you can see we have a little bit of cumulus convection going on ahead of that cold front, as would be expected. So we have that dew point, we have that moisture gradient. Again, if we looked at here, there is that moisture gradient near that cold front, so that'll really help to force storms up if they do begin to fire out there. Let's look at instability, finally. So we still have that capping in play, but throughout the day there, it looks like the wrap is showing instability really beginning right around 21Z, around lunchtime. Lunchtime into the early evening, and then storms should really begin to fire with all this increased instability right about nighttime. So, as would be expected. Again, convergence here, you can see where that boundary is pretty clearly. Convergence is maximized along it. Now let's look at our cams. Let's look at our 15Z HRRR run. This one won't get me far enough, so I'm going to be looking at our 12Z. Let's look at over a broad region of the south. Actually, maybe we can do 14Z. Let's try 14Z. 14Z gets us far enough for what we're looking at here. So we have that, a little bit of instability, as I said, right about 18Z, that's 1 p.m. We get some of these storms beginning to fire here in southern and eastern Texas, portions of Louisiana. Also up north up here. Actually, this is a good sector. This is probably what I want. Also some storms up here where that cold front will be. Yeah, pretty clearly where the most forcing is going to be up north, but we still do have that good surface boundaries down here. Some discrete cells until they are all kind of begin to congeal into this QLCS, and that's going to be where our main risk lies. It's going to be this QLCS risk. So pretty broad wind risk is really our main factor at play, but maximized here in this vicinity from that QLCS. So right about here, you have some discrete storms possible, and then after you congeal, you have probably the most intense storm somewhere around here in northern Mississippi. That's where you get that QLCS tornado possibilities there. And as that progresses, it's still linear, but still has that wind risk for sure. Let's take a wrap forecast sounding. I do like to take those. But when right here, central Mississippi 0Z, we'll look at what we're looking at. And we'll take one. Let's compare it to what her has. Probably right here. Let's do one right there, about 4 hours later. So here is our Jackson. Well, not Jackson, but pretty close, I think, to say. Unless I'm wrong on my city. Oh, I am wrong on my city. Excuse me. I don't know my Mississippi geography that well. So northern, kind of central Mississippi sounding here. We can see our shear. So pretty good looping photograph. Not really large, but you have that curvature, especially in low levels. And if these are a linear storm system, then we're going to be taking into account that lower level shear. In some storms you'll have LCLs up here at 1 kilometer, and that really cuts off a lot of your shear. You really have storms only taking into account this portion of the photograph, but that is not the case for us today. These storms will be taking into account most of the photograph, if not all of it. But we definitely have that shear. It's not that speed shear especially, but you can see for the most part this is a linear setup. While we do have that little bit of curvature in the very low levels, the vast majority of this photograph is right to the east. They're all westerly winds here, as be expected, but pretty high storms here. Narrow capes, so not really what you want to see for really intense storms. This could be some of those discrete storms we saw ahead of the line. Here's later, again, very similar story. In both cases we have about 63 cape. Um, Effective shear or SRH values of 200 meters squared per second squared in our lowest 1 kilometer. So it's pretty good for low level circulations. And the 3 cape would definitely help any surface vorticity to stretch vertically. The thermodynamic profile, though, is not super impressive. Again, the cape is not very intense. This wouldn't lead to really intense updrafts as you would expect. But the mass convergence might help to really force air up and still get that hail risk that is associated in any possible, stronger downdraft as well. One thing you can notice here is that our instability, our cape is at about 1100, 1200. Remember, cape is going to be a measurement of instability. So that's 1100, about, we'll say 1150 joules per kilogram there. Our downdraft cape, though, is 850. So a lot of this instability going up is going to come back down, and that's where that wind risk comes from. So a lot of this pretty intense, the updrafts that occur will be coming down pretty hard as well. And that will really help to probably bow out some of these storms. It's a similar story for this earlier photograph to get 0Z here, 919 down D cape with cape values of about 1400. So compared to the regular cape here, the surface-based cape is 1350. Downdraft cape is going to be 900. So as a percentage, it's going to be less for those earlier storms and more for later storms. In either case, we're going to have that risk for wind-driven damage. Here's our NAM cam, and it's not nearly as impressive as the HER was, but you can still see the similar idea. You get some storms beginning to fire out ahead, and then kind of that congealment into a line. Although the NAM doesn't really have a very well-defined line either, so definitely still some uncertainty to be had with this setup. Not to mention this cloud cover isn't the greatest thing to be looking at. Let's see how high some of this is. This is all very much... A lot of this is very low-level clouds. You can see by the fact that we're in blue. So this is the day cloud phase, and this takes into account 3 different bands of visible satellite, or RGB satellite, but these colors indicate higher level clouds, similar with here. So these are our stronger storms we have going on. Pretty intense precipitation out there. The greens are going to be, things that are getting to that point of, that's a bad color choice. The green clouds, the green that you see on here are storms that are getting into the what's called supercooled region of our atmosphere, and that is when you actually have water below freezing, liquid water in the atmosphere, below freezing, but not in ice form yet. And that is a really important process for precipitation. I can go more in depth in a future video, but what you need to know is that these are basically mid-level clouds starting to form. If you look at let's actually zoom through our loop here. See, some of these are actually forming into those ice clouds as you get higher up. Oftentimes when you get convective initiation, you'll see that green first, and then you'll see these more red colors. But over a broad region of our risk area here, we're very near the surface. This blue colors indicate water, and pure water, not super cooled. And this is going to be above freezing, so we're still in our low levels of the atmosphere down here. That's what's being indicated by the day cloud phase right now, is that these clouds down here, the temperatures, they're still very low level clouds. But you can see in some of our more northern portions here as well. Maybe starting to get higher up into our atmosphere in that region right there. So again, as of now, we still have pretty good stability in place. So this threat will increase as the time goes on. I would take the HRRR more into consideration than the NAM right now. I found recently the NAM doesn't really have the best indication of what goes on, and this is definitely a somewhat fearful set like look right here. Take one more sounding. I'm really curious why we're not seeing this environment. This almost looks like multiple discrete updrafts, possibly rotating. I mean, let's look at 6-hour updraft helicities. This is how much rotation you have, and yeah, we have lots of rotations on the HRRR. It's very possible the HRRR is being more intense, even on the NAM too. So this kind of indicates where our tornado risk is coming from. You can see a broad majority of these are going to be over northern Mississippi. These updraft helicity swaths. I believe this is our 23Z. Yes, it is. A little bit more looping here. A little, I mean, maybe better instability, maybe not. A little bit hard to tell, but definitely interesting. So, but in both cases here, we do have this updraft helicity being pretty prevalent. Actually, this makes me curious. Let's look at the HREF. This is the high res ensemble forecast. I often use this just to see updraft helicity probabilities, which is really useful. So this takes into account 5 different models, or actually 10 technically, but 5 models in their past models there. Taking the southeast here. Scratch that. Let's go southern plains. Double scratch that. Let's go southeast. Let's look at our probability of updraft helicities. And you can see a pretty broad region of updraft helicity, really large, even into Texas, but definitely maximized here over Mississippi with 50% chances of updraft helicities there. So pretty broad region for updraft helicity. The QLCS will be the main threat tonight, but some of those discrete storms early on might pose that tornado risk as well. So if anything to get from this forecast, it's going to be, we're going to be seeing a wind day. Some of these stronger updrafts might have some associated hail. QLCS tornadoes are very much possible today and tonight, especially for the regions in the south. So keep an eye on the weather if you're down in the risk areas. That's about it for this forecast. Again, if you like this sort of product or want to learn more, just let me know in the comments. I'm free to talk about anything meteorology. I absolutely love meteorology. So with that, thank you all for watching, and we'll see you all next time.